Okay, so you have three formulas, or three gas laws, and you have to know how to use the formulas for each, but you do not have to memorize the formulas for the three gas laws. What you can do is you can use what's called the combined gas law, and your combined gas law formula is given to you on your formula sheet, which I will have a copy on Canvas. So formula sheet, periodic table. So on your formula sheet, if you look right here in this box, you'll see that the first thing is your conversion between Kelvin and degrees Celsius. So that's how you do that one. Your second thing is you have all of these units of pressure. So this is how you're going to convert between those units of pressure. That is on your quiz as well. So here are your numbers. You just have to know how to convert between them, which we'll do in one of these problems. And then right here, you have your combined gas law. So it's P1 times V1 over T1 equals P2 times V2 over T2. So that combined gas law is literally what it is. It is a combined gas law of all three. So they take all three of your gas laws, combine it into one big one. So you don't have to know the formulas of each. All you have to do is look at your combined gas law in your formula and pull out which one you need depending on the problem. So the first worksheet is number 2 in your notebook. So this is Boyle's law. So Boyle's law, if we look at the first problem on your worksheet, it says that if a sample of gas has a volume of 100 milliliters, so we're going to go ahead and write that down, 100 milliliters, when the pressure is 200 torr, what is its volume when the pressure is increased to 250 torr? So we don't really have a true event here, but it tells us that our pressure is going to be increased. So that means that your P2 is going to be an increase from your P1. So your P1 is going to be the smaller of the two numbers, so that's going to be our 200 torr, and your P2 is increased to 250 torr. So then your other thing is your 100 milliliters. That is the volume before you increase the pressure, so that's your V1. And your V2, your volume after you increase the pressure, that's the one you want to solve for. So now that you have all your numbers and you know what you're solving for, now you need to, before you do anything, you need to figure out if you have to convert anything. So one of the main things you have to convert is your temperature. You have to convert from degrees Celsius to Kelvin. Well, in Boyle's law, we are not dealing with temperature. We did not get any information about temperature. So what formula am I going to use? Well, if I don't have temperature, or if it says that temperature is constant, which if we look back on our problem, it tells us that assume that temperature is held constant. So it's telling us that our temperature is constant, and it's not giving us any numbers for temperature. So what that means is I'm going to go over to my combined gas law that's on my formula sheet. I'm going to cover up my T's, and that's going to tell me what my formula is. So I'm going to ignore the T's and write everything else out. So my formula is P1 times V1 equal to P2 times V2. So I don't have to memorize this. I can just look at my combined gas law, ignore whatever I'm not given, or ignore whatever is held constant, and then write the rest of it out. So that's my formula. So now I'm going to plug in my numbers because I don't have to convert anything. So P1 was 200 torr, V1 was 100 milliliters, P2 is 250 torr, and V2 is what I'm solving for. So you can think of this as solving for X. So this is our unknown, this is X, so I'm going to solve for X. So how do I get this by itself? Well, it is attached to this, and those two things are being multiplied. So in order to get it by itself, I have to divide by 250 torr. What I do on one side, I have to do on the other. So that's 250 torr. So that gets rid of that on that side, and it gets rid of my units of torr on this side. So now all I have to do is do my math. But real quick, what I want to do is I want to make sure that I'm doing my math correctly. So I want to make sure that my answer makes sense. What I mean by that is I have behaviors that my laws are going to tell me about. So for Boyle's law, if I have P1 times V1 equals P2 times V2, the behavior says, or the law says, that whatever one thing does, the other thing is going to do the opposite. So these are going to behave in opposites. So you have to know that for the quiz. You have to know what the behavior is. So Boyle's law, P1 V1 equals P2 V2, they are going to behave opposite. So what that means is if my pressure is increasing, so it went from 200 to 250, my pressure is increasing, that means that my other thing is going to do the opposite. So my volume is going to decrease. So my number has to be smaller than 100. So when I go and I do my math, I have to make sure that my answer is smaller than 100. If it is, then I know that I did it correctly. I'm looking for my phone. Oh, my phone is recording right now, so I need a calculator. Hold on. Here we go. So I'm gonna find one that works, first of all. Okay. So then I'm going to do 200 times 100 divided by 250. So 200 times 100 divided by 250 is 80. And then the units that I'm left with are milliliters. So my answer is 80 milliliters. My 80 milliliters is less than my 100 milliliters, so I know that I'm good. Okay, so my second worksheet is on Charles's law. Let me get that one. So Charles's law. Okay. So let's just read the problem and we're going to pull out the formula that we need from our combined gas law based on what the problem is telling us. So number 2 on the worksheet, the first problem. If a sample of gas occupies 100 centimeters cubed at 200 Kelvin, what volume would it occupy at a temperature of 150 Kelvin? So again, we're not really given a true event. It's just telling us that our temperature is changing. So what our temperature is doing is going from 200 to 150, so our temperature is decreasing. So this is our T1, this is our T2, this is our V1, and this is our V2, which we are solving for because it says what volume would it occupy at a temperature 150 K. Assume that pressure, and for right now we're just going to ignore the moles, but pressure is constant. So if pressure is constant, what I'm going to do is I'm going to ignore my P, or my pressure, inside my combined gas law. I'm going to go to my combined gas law, I'm going to cover up my P's, I'm going to write everything else. So if I cover up my P's, that means that I have V1 over T1 equal to V2 over T2. I covered up my P's, so I got V1 over T1 equals V2 over T2. So that is going to be my formula for Charles's law. So then I just plug in my numbers. But before I do that, I have to make sure I don't have to convert anything. So now I have temperature. I have to make sure that my temperatures are in degrees, not degrees. I have to make sure that my temperatures are in Kelvin. Well, they already gave it to me in Kelvin, so I'm good. So I don't have to convert anything. So then I have 100 centimeters cubed over 200 Kelvin. Anything cubed is something, if a unit is cubed, that is a unit of volume. So centimeters cubed, meters cubed, decameters cubed, it doesn't matter. They're all units of volume, okay? So 100 centimeters cubed divided by 200K is equal to V2 divided by 150K. So then you cross multiply. So V2 times 200K equal to 100 centimeters cubed times 150K. Okay? So now I want to, okay, So now I want to solve for V2. So in order to get rid of, or in order to get V2 by itself, I have to get rid of whatever it's attached to. So divide by 200K. Whatever you do on one side, you have to do on the other. That is going to get rid of my Kelvin units. So V2 is going to be equal to 100 times 150 divided by 200. But I want to make sure that my answer will make sense. I want to double check that my answer makes sense. So I'm going to look at the behavior of this. So if volume is over temperature, if something is over the other thing, they're going to behave the same way. Okay? So for Charles's law, the relationship between volume and temperature is if one thing increases, the other thing is going to also increase. If one thing decreases, then the other thing is going to also decrease. Whatever one thing does, the other one's going to do the exact same thing. So what's happening to our temperature? Our temperature is going from 200 to 150. So our temperature is decreasing. So that means that our volume is also going to decrease. So I want a number less than 100 again. So now let's do that math in our calculator and see if we get a number less than 100. So 100 times 150 divided by 200, and we get 75, which is less than 100. So I am pretty confident that this is the correct answer because it makes sense. And I'm just going to use whatever units I have left over, which is centimeters cubed. Okay. Lastly, Gay-Lussac's law. So let me get the third worksheet. So Gay-Lussac's law. Let's read the first problem and see what formula we need in order to do these problems. So prior to a trip, so it tells us that our event is some trip. Okay, let me make sure you can see that. Hold on. Yeah, okay, good. So our event is some trip. So prior means before. So we're going to look at the numbers before the trip. So prior to the trip, the pressure in a truck tire was 1.8 atm when the temperature was 20 degrees Celsius. So before the trip, the pressure was 1.8 atm, the temperature was 20 degrees Celsius. When the trip was over, so after the trip, so if I was given a number for my pressure and a number for my temperature, I should have a second number for my pressure and my temperature. Okay. When the trip was over, the pressure was 720 millimeters of mercury, so mmHg. Assuming constant volume. So it tells you that your volume is constant. What was the temperature? So you're going to solve for T2. All right, so if our volume is constant, that tells us that we can ignore our volume units in our combined gas law. So we're going to ignore our V's, and we're going to write the formula that does not contain any V's. So if we ignore this V, that is your P1 over T1 equal to, and if we ignore this V, that is your P2 over T2. So Gay-Lussac's law is P1 over T1 equals P2 over T2. So you need to be able to pull out whatever formula you need based on what the problem tells you. All right, so now that I have my formula, now I need to figure out if I have anything to convert. Well, I have temperature, so I need to make sure that my temperatures are in Kelvin. This is in degrees Celsius, so I need to know how to convert between Celsius and degrees Celsius and Kelvin. So if I look at my formula sheet, the formula to convert between degrees Celsius and Kelvin is right here. So if I have degrees Celsius, I just have to add 273. So that's what I'm going to do. I'm going to add 273, and I'm going to get a new T1 of 293. So I'm going to use that 293 as my new T1. I'm also going to make sure that everything else, the other thing that I have, are in the same units on both sides of the event. So if I have 1.8 ATM here and 720 millimeters of mercury here, those are not the same. I have to make them the same. So I have to convert one to the other one. It doesn't matter which one you convert, because at the end it's gonna work out fine, as long as they are the same. So you can convert this one into millimeters of mercury, or you could convert this one to ATM. I personally am gonna convert this one into ATM just because I like things to be in ATM. That's just my personal preference. You can definitely change this to millimeters of mercury and it will work out the same. But I'm going to convert this into ATM. So for your quiz, you have to know how to convert things. So start with what you're given. So 720 millimeters of mercury. Do your picket fence. Whatever you want to get rid of goes diagonal. So millimeters of mercury go down here. Whatever you want to be left with goes up there. Now, I'm going to look at my formula sheet, and I'm going to look at my units of pressure here, and I'm going to see that 1 ATM is equal to 760 millimeters of mercury. So I'm going to write the number 1 on the top, because 1 ATM is equal to 760 millimeters of mercury. So my 760 is going to go on the bottom. So what that means is, in order to convert from millimeters of mercury to ATM, I have to divide by 760. So 720 divided by 760, that gives me roughly 0.95 ATM. So this is the number I'm going to use in place of my 720 millimeters of mercury. So now I have everything converted, so now I can use all my numbers and plug it into my formula. So my P1 was 1.8 ATM. Divided by T1, my new T1 is 293 Kelvin, equal to P2. I can't use 720 millimeters of mercury. I can't use this. I have to use the one that I converted, so 0.95 ATM. These units have to be the same. And then I'm going to solve for T2. Okay. So before I do that, I want to make sure that my answer is going to make sense. So I need to look at the behavior. So what is the behavior for Gay-Lussac's law? If I have something over something, they are inversely proportional. No, they're directly proportional. This one is inversely proportional. That's why it's opposite, because it's inversely proportional. These two are both directly proportional. So what that means is that whatever one thing does, the other thing is going to do the same. So this is also going to behave the same way. Okay? So these two laws behave the same. This one behaves differently, or opposite. Okay? So if I look at my pressure, this one and this one, if I did not convert these two to have the same unit, and I just look at the numbers, so if I look at 1.8 and 720, I would assume that my pressure was increasing. But that is not what's happening. You have to make these units the same. You have to look at similar units. Because if you notice, this is 1.8 ATM, and then after you convert it, now it's 0.95 ATM. So your pressure decreased, and if your two things are going to behave the same, that means that your temperature should also decrease. So you're looking at a number that is less than 293 Kelvin, because you're using Kelvin in your formula, so your answer is going to be in Kelvin as well. So I'm looking at a number that is smaller than 293 Kelvin. So I'm going to grab my calculator, and I am going to, first of all, I'm going to cross multiply. So T2 times 1.8 ATM is equal to 0.95 ATM times 293 Kelvin. So I have that. In order to get T2 by itself, I have to divide by 1.8 ATM on both sides. That's going to get rid of my 1.8 ATM on that side. That's going to get rid of my units of ATM on that side. So now I just have to do the actual math, and I'm looking for a number that's smaller than 293. So 0.95 times 293 divided by 1.8 is 154.6, and then whatever unit is left over, which is my Kelvin, is going to be the unit that I'm dealing with. So 154.6 is less than 293, so I know that my answer makes sense. So I'm pretty confident that it is the correct answer. So that is how you do Boyle's law, Charles' law, Gay-Lussac's law. Each of them using your combined gas law. So you have to pull out the formula from the combined gas law, use it according to what your problem gives you. The tricky part is going to be if your problem gives you numbers that you don't necessarily need. So for Boyle's law, let's say that our problem gave us a temperature, but only gave us one value for temperature. So it didn't say that temperature is constant. Instead, it gave us only one value. Well, if it only gives us one value for temperature, and it doesn't ask us to solve for the second temperature, because it still asked us for what the volume was. So let's say, for example, it gave us a temperature of 25 degrees Celsius, but then for T2, for my other temperature, because I already know that it's asking me for the volume. It says, what is the volume after the event? It says that. So I know my V2 is what I'm solving for. But it gave me this one, but it didn't give me anything for my other temperature. It only gave me one number for temperature, and it asked me to solve for volume. So I know that this is still going to be Boyle's law, because this was put there to distract me, to make me mess up. So that's where you have to be careful. You have to read and see which one is it, what numbers is it giving you, what number is it asking for. So if you have two pressures, one volume, and it's asking for the other volume, then it's Boyle's law, and you do this. Even if it only gives you one temperature, it gives you one temperature and doesn't give you the other one, then obviously you can't do anything with it. You can't solve for two unknowns. You're only going to have one unknown. So just read the question carefully and pick out what two values it gives you, what value is it asking for. That is the formula that you're going to use. The other thing is if you have STP. So STP stands for standard temperature and pressure. Standard temperature, so if you see standard temperature, that is 0 degrees Celsius, which is also 273 Kelvin. Standard pressure is 1 atm. So standard pressure is 1 atm, but you may need to convert it into another unit in order to do your problem. But standard pressure is 1 atm. And then lastly, DM3, that's decameters cubed. Anything cubed is a unit of volume. Okay? So make sure you know how to do the 3 formula calculations. Make sure you know how to convert different units of pressure and temperature. And then make sure you know the behaviors of all 3 laws. Okay? So that's what your quiz is on tomorrow. Those are the 3 worksheets that you got. All right.